Okay, so the new thing for the day is figuring out how to solve more complicated word problems than what you've done before. In general, there are two categories of problems. There's if you have no acceleration, i.e. you have a steady speed, car moving in a straight line, steady speed, you're going to use this equation. If you have constant acceleration, like, say, ball rolling down a ramp, you actually have 4 new equations to pick from. All right? And these equations all have different variable combinations. They all have 4 variables in them. All right? So, what do you do if you don't know how to solve a problem? You guess. That's right, you guess. What's the G stand for? Givens. U is unknowns. E is equation. And SS is substitute and solve. All right, so we're going to try this first question. Example 1. A ball rolls at 1.2 meters per second for 0.8 meters. How long does it roll? All right, before we even begin, does this problem say anything about acceleration? No. Okay, so which set of equations should we use? All right, are we going to use a constant speed equation or the one if you have acceleration? Use the constant speed. Okay, so that's where we're going with this. So go ahead, underline all the known quantities, all the givens and unknowns. And then I want you to fill out G.U.E.S.S. Okay, so you should have the speed is 1.2 meters per second. I use V for that, for velocity, same thing. Speed, velocity is 1.2 meters per second. Displacement or distance is 0.8 meters. Time is the unknown. And we can use, because it doesn't mention anything about acceleration, you can use the constant velocity equations. V equals d over t. Plugging stuff in, you should come out with a time of 0.6666666 seconds. 0.67. Right, have I mentioned sig figs in this class? Yeah? And do you remember what I said? No sig figs? Just give me 2 or 3 digits. Don't give me the entire contents of your calculators, because that's, annoying. All right? Okay, everybody good on this one? All right, next up. A ball is released at the top of a 1 meter long hill. What is its acceleration if it takes 2 meters to reach the bottom? Go ahead, write your givens and unknowns first, and then see if you can pick an equation. Okay, so for this one, I've got released means your initial velocity is 0. Displacement is 1 meter. Time is 2 seconds. Acceleration is the unknown. I'm actually going to pause it, scroll down so you can't see, and hit pause. What I want to know is, with those givens and unknowns, which of the 4 equations are you going to use? Okay, so we had VI, D, T, and A. I'm going to go to the list. Can you use the first one? Why doesn't that one work? Yeah, you don't have final velocities. You can't use that one. Can you use the second one? Yeah, it's got D, VI, T, and A. So that would be the one that you would pick for this problem. Does that make sense? All right. So, yes. Yes. You don't have to memorize these for tomorrow. But you are going to do so many problems that I'm going to recommend memorizing later. All right, so tomorrow I'll give you these 4 equations. All right, any questions? So at this point, it's just a matter, we know the givens and unknowns, we've picked out the equation to use, just plug stuff in and solve. All right, so once again, when I grade these, this is actually a 2-point problem. I'm going to give 1 point for getting givens and unknowns correct, and then the remaining point for actually solving the problem. All right, so make sure you get your givens and unknowns written down. And you have to write them this way: VI equals 0 meters per second. If you just wrote 0 meters per second, I have no idea what you're talking about. Is that an initial velocity? Is that a final velocity? What is that? Is it a constant speed? So, yeah, make sure you do that. And that's it.